Hello, guys. Welcome to another episode of Cuda Education. So today I want to just quickly do some housekeeping tasks. We have to make sure that we kind of have some understanding of what's going on behind the scenes. So just to do some quick give us some good context on what's going on. So one of the things I've noticed is that in the file structure, we have header files, .h files, .m files, and then .metal files. Okay, so header, .m and .metal files. Okay, so I might have misspoken previously, but there is a difference between the three types. .h, .m or .mm, and .metal. And notice that we have the icons here. All right, and so I wanted to make sure that we understood what's going on here, so that we're not just blindly moving along. So the .metal files are compiled by Xcode's metal shader compiler into GPU machine code. They run on the GPU. So our .metal file, AAPL simple, runs on the GPU. All right, .m and .mm files are compiled by Clang into CPU machine code. They run on the CPU. So all of these .m or .mm files run on the CPU. I'll get into the difference between .m and .mm later. And then .h files are headers. They don't run anywhere. They just get included into whatever file imports them. So normally, like for the view controller, you'll have the main view controller file, and then you'll have the header file that's just included in it, right? So it's just like an include, but you could choose to include or not include it. It just makes life easier from just an organization level, syntax, all that, coding standards. It just makes life easier. The interesting one is APL shader types.h. It gets imported by both sides. So shader types.h, the CPU code, APL renderer.mm imports it to know the buffer index values and struct layouts. The GPU's code, APL simple.metal, imports the same file for the same reason. This shared header is how the two sides agree on the data contract between them. Okay, so so header files can be included in .m, .mm files and also in metal files. Okay, so we're good. So what is the difference between .m and .mm files? So .m files is Objective-C source file, and .mm is Objective-C++ source file. Objective-C plus C++ mixed together. The plus lets you use C++ features using namespace, SIMD, C++ constructors like float, 4x4, all of this other stuff, and so on. In our project, camera, APL camera.mm and APL renderer.mm use .m because they work directly with SIMD C++ API. Blah blah blah. The plain.m files, viewcontroller.m, mathutilities.m, don't need any of that, so they stay as regular Objective-C. All right, and then I get into what is SIMD. SIMD stands for Single Instruction Multiple Data. It's a hardware feature in modern CPUs and GPUs that can operate on multiple numbers at once. For example, instead of adding two floats one at a time, right? So we have the X's, the Y's, and the Z's for A and B. An SIMD instruction does all three in one operation. So we have all three results X, Y, Z. Opera provides the SIMD.h library that gives you types like float 3, float 4, float 4x4, etc. These map directly to SIMD hardware registers. When you multiply a float 4x4 matrix by a float 4 vector, it is not doing 16 individual multiples and 12 adds. The CPU processes multiple lanes in parallel. In our project, SIMD types show up everywhere: camera position and directions, colors, matrices, in shaders. The nice part is the types are compatible across CPU and GPU. A float 4x4 in AAPL camera.mm has the exact same memory layout as float 4x4 in AAPL simple.metal. So you can write a matrix on the CPU, put it in a buffer, and the GPU reads it directly with no conversion. All right. Is SIMD a feature of ARM-based chips that differentiate it from X86 chips? No. Both architectures have single instruction, single instruction, multiple data. It's not unique to ARM. They just have different implementations. So you have x86 Intel. That's this stuff here, and ARM Apple Silicon is this stuff here. Apple's SIMD library abstracts over both. When you write float 4x4 times float 4, the compiler emits SSE instructions on an Intel Mac and a Neon instructions on the Apple Silicon. Your code doesn't change. SIMD as a concept goes back decades. It's a fundamental feature of virtually all modern processors, not something specific to any one architecture. GPUs take it even further. A GPU essentially is a massive SIMD machine with thousands of lanes running shader code in parallel, right? So you guys might know that GPUs, the big thing about GPUs is that things run in parallel, right? Which makes it so fast. So for 1 second of time, you're doing many different things simultaneously. Whereas generally speaking, CPUs are more linear. It's one after the other, right? And we need both for various reasons. So anyway, guys, I just wanted to do some housekeeping, clear things up a little bit so we have a little better context on all of this, all that we do in Apple Metal, and we can understand things better. One of the main things to note is that the .metal files are GPU based. The .m or .mm files are usually CPU based, and then the header files can be included in both the .m, .mm files, or it can be included in the .metal files, right? The difference between .m and .mm is that one is Objective-C, and .m is Subjective-C, and .mm is both Objective-C and C++. So you can get the features of C++. Let me just Objective C++. All right, guys, this is Cuda Education. Thank you for watching. We do have some work to do on doing some details for a previous episode that we did. I will get to that, but wanted to make sure we did some good housekeeping just so we have better understanding of what's happening going forward. Have a great day.